Can people live on the moon? Not just survive, but really live comfortably on the moon, in a community, a place that you could call home. We obviously want to establish research facilities, even mining and manufacturing operations on the moon. Those, in my opinion, are long overdue. But so far, I've only ever really thought of the moon as a place like Antarctica. For example, a place where people go to do work for long periods of time, but no one actually lives because it's so inhospitable. There are no cities. But could we build one? Could we do anything that would make our moon at least a little bit more hospitable for human life? Is this a place that we might call home one day in the future? Let's talk about it. This is Lo Spazio. So the other day I was thinking a lot about something Elon Musk said recently, that we could establish a self-sustaining city on the planet Mars if we can just move 1 million tons of cargo over there from the Earth, which is a lot of stuff for sure. But it's not an impossible amount of stuff. If Elon can follow through on his promise to build 1,000 Starship rockets, then each one would only have to deliver its cargo capacity of 100 tons 10 times, and then we're good to go. The biggest obstacle is the transfer window to Mars that only opens once every 2 years, plus the 6 to 9 month travel time. And when we factor in that multi-year round trip for each of those starships, then we realize that it will actually take several decades to accomplish. Obviously, that equation can change. SpaceX can invent totally new, way better spaceships at some point in between. But going with what we know now, building that Mars city will be a generational project. But what about the moon? Elon Musk is obviously pretty stoked that NASA hired his new rocket to land people on the moon for the first time, but on the whole, he doesn't seem too interested in it. I think it's got some good potential, so if we need 1 million tons of stuff to build that Mars city, then how much would we need for a moon city? It's tempting to say we wouldn't need as much stuff, that we could get by with less because the moon is much smaller, but I don't think that's how it works. So we could probably stick with 1 million tons, that would be the same. But with the moon, the complication with time is completely removed. Instead of a 4 or 5 year round-trip mission to Mars, we could do round trips from the Earth to the moon in 4 to 5 days. It's just 240,000 miles away. With that kind of turnaround, a fleet of 1,000 ships could get the job done in a couple months, though that would probably be the cart before the horse. I don't think we could realistically even pack them all that fast. It's a bit overkill. So instead of 1,000 ships landing 10 times, we could just do 10 ships landing 1,000 times, or 20 ships landing 500 times. Any way you slice it, we get to that 1 million tons onto the moon in less time than it takes to fly to Mars and back even once. Starts to make a bit of sense, right? Now, that's not to say that Elon Musk is wrong for going after Mars, because for every advantage that we've got from the moon, there are probably even more significant downsides. We first have to deal with insane temperature swings on the moon. During the night, the temperature drops to negative 280 degrees Fahrenheit or negative 175 Celsius. And during the day, the temperature skyrockets to positive 260 degrees Fahrenheit or 126 Celsius. And one full day on the moon equals out to 29 and a half days on Earth. So we get extremely long periods of time at each extreme. And that's not good. Particularly the daytime temperature, because we all know that computers do not like heat and that they are difficult to keep cool. Mars doesn't have this problem. It's mostly just very cold, with the temperature peaking in certain places at certain times to only about 70 degrees Fahrenheit, or about 20 Celsius. So if we're going to have a legitimate living situation on the moon, it has to be very heavily insulated. As nice as it would be to have a dome over the city so that we could all see out into space, it's hard to imagine anything that would be effective at keeping the heat out while also being practical. Whatever this dome is made of would either need to be launched off of the Earth or manufactured on the moon. Either way presents a massive challenge. The more practical solution would be to build a very low and dense settlement and then cover it over with lunar regolith. That's the dust and small rocks and stuff that cover the surface. A heavy layer of regolith works well as an insulator. We could maybe even mix it with a binding agent to form a more dense concrete-like material. Aside from thermal insulation, we need this barrier to protect against a bunch of other complications from meteorites and solar activity. On Earth, our atmosphere does all of this work for us, but the moon doesn't offer the same help. The moon does have an atmosphere, but just barely. The exosphere in the moon has about 100 molecules per cubic centimeter. Compare that to the Earth, where we have 1 billion molecules per cubic centimeter. Significant difference. And the key factor here is magnetic field. Earth has a powerful magnetic core that repels solar wind. The moon does not. Even if we could add density to the atmosphere on the moon, it would just blow away fairly quickly. This is a problem for Mars as well, but it is still much better off. The Mars atmosphere is also super thin, but still much more substantial than the moon. Plus, Mars has some size and gravity on its side. We might at least have a shot of adding density to the Mars atmosphere at a faster pace than the sun can blow it away. The moon can't even really imagine it happening. Gravity is another problem. Not only would it be too weak to hold an atmosphere together, it might be too weak to hold our human bodies together. The force of gravity up there is only about 15% as powerful as the Earth, and that makes it only about 1/2 as powerful as Mars. What effect does that have on people? It's a tough call. So the longest single amount of time spent in Earth orbit, so more or less zero gravity, was 437 days. This was done by a Russian named Valery Polyakov. The whole point of him doing so was to study the effects on his body. And as far as we can tell, that amount of time spent in microgravity did not have any permanent or destructive side effects. He is still very much alive at the age of 79. It's reported that he did not suffer any prolonged performance impairments after returning to Earth. So it doesn't seem unreasonable to think that we could actually live in a moon city. We need to keep ourselves protected from the elements, and we need to monitor for the prolonged effects of low gravity on the human body. But the nice thing about the moon as opposed to Mars is that we don't have to stay for the long haul. Any trip to is a minimum 2-year duration on the surface, plus 1 or more transit time round trip. We don't know what that's going to do to a person, and once they're in, they can't bail out. With the moon, we might not be able to say indefinitely, but there doesn't seem to be any reason to doubt that we could live there for a year at a time with no harm done. Maybe we could populate the city in shifts. 1 year on, 1 year off. Something like that. It only takes a couple of days to travel back and forth, so there's plenty of room for flexibility. It's almost funny just how easy it is to reach the moon. It takes us 2 weeks to cross the ocean in a boat. It took world record holder Jared Isaacman 60 hours to circumnavigate the globe in a jet plane. It takes about 3 days for a rocket to reach the moon from Earth. In the Star Trek movie First Contact, Captain Picard says that there are over 50 million people living on the moon. This was imagined to happen in the year 2373. Could something like that actually happen in the next 300 years? Well, given the size of the moon, which has about 15 million square miles or 38 million square kilometers of surface, we can definitely fit 50 million or even more people pretty comfortably. The continent of Asia offers about 44 million square kilometers and is home to around 5 billion people. So how do we do that? Well, starting with the basics, air, water, food, and power, it's already looking pretty possible. So we can actually get oxygen from the surface of the moon. Each cubic meter of lunar regolith contains 1.4 tons of minerals on average, including about 630 kilograms of oxygen. NASA says humans need to breathe about 800 grams of oxygen a day to survive. So 630 kilograms of oxygen would keep a person alive for about 2 years. Pretty cool, right? And we can use the process of electrolysis to extract that much needed breathable gas. We also have a reasonable supply of water up there as well. There is probably water ice just waiting for us in the bottom of craters on the moon. It would have been brought there on asteroids and then preserved in a frozen state by the shadow of the crater. We can also extract water from the regolith as well. Just by baking the surface of the moon, it should produce water vapor that we can trap and liquefy. And then, of course, we have the good old astronaut standby of purifying urine back into drinkable water. I know, but it's just the reality of living in space. Astronauts drink pee. Deal with it. Next up, we need plants. NASA has already found that their packaged dried foods will lose their vital nutrients over time. So while we could still get the calories we need, we would start to lack in vitamins, and that means scurvy. And no one wants to be dealing with scurvy on the moon, so we need to have fresh plant food growing to keep our bodies healthy in the long term. NASA is already figuring this out with some experiments in growing plants on the ISS. They've so far been able to grow leafy vegetables pretty well, and just that alone would cover our basis for nutrition. Then there's the technology that we would rely on. Communications is going to be key, not only for sending and receiving vital information, but also for keeping people sane. We need to be able to have video calls and live streams and ways to keep people on the moon feeling like they are still part of the human race. And that is where Starlink comes in. As early as late 2022, SpaceX will be testing the laser-based communication system in their Starlink satellites with a high-altitude orbital mission. This is the Polaris Dawn flight that will take a Crew Dragon capsule to the highest ever Earth orbit, at which point they will test the Starlink network and its new optical laser function to see if we can get high bandwidth and low latency communication between the Earth and outer space. If that test proves successful this early in the game, then we should be more than set with a Starlink constellation around the moon communicating with the Earth network. As for the power on the moon, we would also use solar energy to start off with, for sure. We could test out some miniature nuclear reactors that NASA are developing as mobile power generating stations, but in the long term, we could try and harness something called helium-3. This is an element found in the regolith of the moon. It's created by the radiation from the sun absorbing into the surface. We know that the sun is just a gigantic fusion reactor, and that same power could be contained in this helium-3. We don't have it on Earth because, luckily for us, the sun's radiation doesn't reach the surface in any significant amount. But we are pretty sure that H3 can fuel a power plant, and it could do so very effectively. We think that just 100 kilograms of helium-3 can power a small city for 1 year, and there is plenty of it to go around up there. So, what do you think? Is the moon actually a better colonizing candidate than Mars? It's got some advantages that can't be overlooked, so let us know your theories in the comments below. Meet us back here every week for more updates on everything aerospace industry and interstellar exploration related. Make sure to give the video a thumbs up today if you liked it. That really helps us out for real. And subscribe to Lo Spazio for more videos just like this. We do one long-form essay and one news update every week, and if you'd like more, we've got 2 more on the screen for you right now.